Mechanism of action of cell-based therapies. Stem cells are self-renewing undifferentiated cells that can have the potential to differentiate into any organ-specific cell, depending on their origin. They can be characterized as either embryonic or somatic or adult stem cells. They differ in their potency and differentiation capacity depending on the tissue of origin. Thus far, hematopoietic stem cells, or HSCs, and mesenchymal stem cells, or MSCs, have emerged as promising cell-based therapies for severe refractory IBD cases. HSCs can be isolated from the bone marrow, umbilical cord blood, or more commonly peripheral blood of an individual, and eventually transplanted back to the same individual, autologous. These stem cells can also be received from a matched donor, allogenic, for potential cell-based therapy. HSCs are progenitors of both the myeloid lineage, monocytes, erythrocytes, macrophages, neutrophils, and dendritic cells, and the lymphoid lineage, T cells, B cells, and natural killer cells, and are capable of migrating to damaged tissue and differentiate into immunomodulatory cells in order to restore normal gut mucosal barrier function and reduce inflammation. Like HSCs, MSCs are also multipotent self-renewing cells that are capable of differentiating into several types of cells and are present in various tissues of the body. MSCs can be isolated for clinical application from bone marrow, umbilical cord blood and tissue, Wharton's jelly, or adipose tissue. MSCs derived from adipose tissue are easily extracted in large quantities with reduced morbidity and discomfort for the donor. The underlying immunomodulating mechanisms of MSCs are still unclear. However, studies have reported that MSCs exert their influence on the target cell by associating with them in a close proximity, and not solely via cell-to-cell contact signaling. Due to their low immunogenicity, MSCs have certain advantages over HSCs in regards to therapeutic transplantation. This property stems from their low expression of MHC1 cell surface proteins, as well as a lack of MHC2 and co-stimulatory proteins. As such, the need for chemotherapy in MSC transplantation is eliminated, whereas it is necessary in HSC transplantation. Another benefit is that unmatched allogeneic MSCs can be utilized in the transplantation procedure. MSCs also offer an advantage to mid-sized transplant centers as they can be mass manufactured more readily. Both HSCs and MSCs have immunomodulatory effects that can downregulate mucosal immune reactivity and promote tissue healing. Indeed, HSCs and MSCs have emerged as a promising therapeutic option for severe refractory Crohn's disease cases, such as refractory fistulizing perianal Crohn's disease. In perianal Crohn's disease, the objective is to deposit MSCs locally in fistulizing tracts to downregulate the local immune response and promote wound healing. However, future studies are necessary to fully decipher their complex cellular mechanisms. Cellular therapies will not be limited to HSCs or MSCs. Other cellular therapies, such as induced pluripotent stem cells or iPSCs, will also likely be explored in preclinical settings. Importantly, future studies should include assessments of long-term safety, the duration of response, and the cost-effectiveness and technical feasibility of such cell-based therapies.